Hey, my name's David. I'm the CEO of Geolumina, and I want to introduce you today to the NVZN viewer and NVZN AI, which is what powers the NVZN viewer. The most baseline level of usage here is like enterprise search. It's a way to discover and interact with your data and information. Enterprise search hasn't changed much since the early 2000s when Google introduced their Google Search appliance, and then maybe Elasticsearch came out, and most recently things like cognitive search and things working through unstructured data from different service providers. And those are all really good and really powerful, but they principally operate on the word-based information and data that is in a system, and that's not always super revealing for the type of work we're trying to do in subsurface companies. And so what we did is we built NVZN AI, which has the knowledge of a geologist and a geochemist, a petrophysicist, a geophysicist, even an engineer. And we use that background knowledge that's rolled up in our artificial intelligence to create structured data that's usable. So in the NVZN system, it's just a web app. You can log in and it has access to the information that's been analyzed from your system. And what this is a three-dimensional workspace. In this workspace, everything is grouped by visual similarity. So we can zoom in and zoom out with the scroll wheel. If we click and drag, we can pan. If we right-click and drag, it rotates the system. It's easiest to demonstrate kind of how this works in a very simple data set. So let me switch over to the typewriter characters data set here in my data drop-down selection box. And it will load this pretty fast. There's something like 55,000 or 60,000 images in this data set, and you can see it only took 2 seconds to load. The latency is really low, the speed is really fast. So if I zoom in, you'll see that there are all of these clusters. And inside each of these clusters is a letter group. And if I hover over a different one, you'll see that R's are up here, and L's are over in this place, and B's are down here. And everything is kind of clustered by its visual similarity. So it's a place where you can go and explore, and without any sort of AI, it's very intuitive to be able to find things you remember. I think we all have those cases where, oh, I remember a slide from some PowerPoint I saw, or oh, I remember a map that my colleague made. And it may be impossible to find with search terms, but it's very simple to find visually. So if we go back over to the geologic images data set, we can kind of demonstrate this workspace. So the z-axis here is actually separated by the artificial intelligence tags. So any system in here is split into what the artificial intelligence category sees. And so block diagrams are there in the back, and we can hover over those and in fact see that they are block diagrams. And if I rotate this thing sideways, we can see that there are multiple layers here. And as I go through, block diagrams, core photos, data tables, geographic maps, outcrops, chromatograms, etc. They all have their X, Y, and Z location where they live and become easily accessible. If we, pick some set of data, let's say seismic cross sections, and we zoom in on that, we'll see some interesting things where there are like tight little clusters of images, and those images are visually similar to one another. So if I expand the X and the Y scale, I'll end up with a little bit more visual resolution of that fact that there are clusters within the cluster. And those allow me to see things. I have an opacity slider here, so I can kind of remove the background noise from the unselected system of things. And you'll see, for instance, here is a cluster of images, and I can hover over them and in fact see that, they're visually similar, and they are in fact actually images from the same Graben in the North Sea. I believe this one is offshore Norway. And, you can just see that if I'm looking for something visually, I can get in here and test out a group, an experiment. The same is true if I turn on, let's pick something else, maybe a contour map. We've got a lot of those in the subsurface, and what we might do is come in here and start looking and see that, yes, okay, there are a number of subsets that look visually similar to one another. And so I can hover over the top of these and see, in fact, that these are time slices, from the same sort of volume. And that's a really powerful way to explore information. Now, if that's not enough, we have the AI tags. We also have this set of user tags. And the user tags are kind of layered information on top. So if I have contour map selected, and I also have, let's say maybe I select Norway, we can see that there's two small clusters still lit up. And so I can get to the Norway contour maps without ever having to type in Norway and contour map or a field name, or I don't need to know what to search for. The tags help guide me in that regard, and then I can visually explore what I want to work on. So that's the kind of getting started with NVZN AI and how it works. So it's essentially a search tool, a discovery appliance that allows you to interact very seamlessly with very large data sets, tens and hundreds of thousands of images that come from hundreds of thousands of files. So, multiple kind of terabyte and hundred of terabyte to petabyte scale data sets can be rolled up into this simple interface. So that's all for kind of the concept behind NVZN. I'll have a couple more short videos that show the exact mechanics of using the sliders, assigning tags, navigating information, etc., etc. So that's just the start. Thanks for watching.